Hey guys, welcome to Nerdish. I am Brennan. Levi will be joining me momentarily. And
Sorry,
there he is.
I'm underdressed. I will
Yeah, you don't have your
change in a
shirt
second.
on.
Yeah,
I actually didn't notice that till just now.
Yeah, me neither.
Great. Today I will be covering exponents and change of base exponents, which are really kind of the most difficult exponent type questions you'll get on the SAT or ACT. I think those are probably more common on the SAT, which is good because the ACT was last Saturday, so we've got some time for the next one. And then what are you covering today?
I cover concision.
I get it. Good joke. All right.
Yep.
So Levi, are you going to stall for me for like 20 seconds for me to do that?
Oh, yes.
He's going to stall real quick.
Stalling.
Because I got to share this video on Facebook.
Also, hello everyone. It's
Tuesday. February 12th.
Tuesday's really hard, dude. Tuesday's always a hard day.
Honestly, I only put in 8 hours a day. I'm feeling pretty good.
That's good.
I got everything done, and I'm just like, ooh, this is nice.
We are doing normal stuff. If you have questions about the ACT that just happened, you want to debrief a bit, or there are some... wow, my word choice is just so off today.
Yeah, if you want to debrief about the test that just happened.
Yeah, or there are concepts that tripped you up, and you want to have us go over those specific concepts, then we can do that. Throw you in. Ooh, we should probably erase what's in the queue. I hope we got to Robot Dancer's question at the end there.
We did.
Okay.
All right, you know what? I'm going to have you do this. You know the two places to share it. My regular page and then Teen.
Yes.
All right. Hey, Marco's broken. I want it to be like Tolkien at the end.
Is that Marcos?
Definitely Marcos we've seen before.
Yes.
Oh, you mean is it Mark who
Yeah,
gave
Marcos.
us the... Maybe? Anyways, hello Marcos, and hello anyone else. So today we're going to be talking about exponents. I will be talking about exponents.
Yes. I will be listening about exponents.
If at any point you have questions, we'll throw them up in the queue. They can be related. They can be about whatever you want. It doesn't really matter. If they're relevant, I'll answer them as we go. If they're not, we'll just save them for later. What is an exponent? That's usually the best thing to answer. So let's say I have x as a variable, or any number really. The exponent is this value here, right? X to the a, the power of a. All right, I'm going to start saying some things that might be a little confusing. If you don't know the vocabulary, the vernacular, let me know, and I will go ahead and try to clear that up. But from now on, I'm going to act like you already have seen these before with how I explain them. So this is what an exponent is going to look like, right? This is the exponent here. So for example, if I had x squared, all right, x to some power, that means that I have that number of them. So this is x times x. Okay, x cubed, you've got it, x times x times x. Pretty self-explanatory. It's just, this is how we write that. This is a way for us to keep track. Great. So hopefully that makes sense at a base level. There's lots of more things that will come off this. So if this right here, or that will build off this, if this right here is not clear, or if this doesn't make sense, please stop me now. Otherwise, you're going to be lost. Great. There's a number of things we can do with this. So let's just say I'm multiplying x's, right? I have this and I have this, and I'm multiplying two variables, two x's. Hey, Uncle Bill, good to see you.
Uncle Bill.
Yeah, he has like some really cool emotes and just says it looks like wind being blown, and it's a multitasker flies by. Well, great. Thanks for stopping by. So as I was saying, we have these two variables here that are multiplied, and the number of them gives us the number or the value of our exponent. So what if we were to multiply x squared times x cubed? Right? What would that be? Now we can break this down, and we can get x times x, right? That's x squared, times x times x times x. And at that point, we can do the same thing we did here, is just count them. And this equals x to the fifth. What you can notice, though, is what I really did here is I said x squared times x cubed. That equals x to the 2 plus 3, the 2 plus 3 power. Right? If I'm multiplying them, the product rule here, I get to actually just add their exponents. It's pretty nifty. Makes it very quick and easy to solve certain problems like this. Well, now we've done multiplication. What about division, the quotient rule? All right, what if I have x to the fifth over x cubed? Well, again, we can write this out, and I get I should have chosen a smaller number, but 5x's over 3x's. At this point, you've divided x by x before. I can cross those off, cross those off, cross those off, and I get x times x, which we said right up here is just going to give me x squared. But that takes some time. Let's think about this. It's very similar to this. If I'm adding them here, I'm actually subtracting them here, right? I have x to the 5th over x cubed. It's going to be equal to x to the 5 minus 3 power, or x squared. Again, if any of this isn't making sense, let me know, stop me. Trying to do this in a progressive order so that, it gets more difficult as it goes. But again, these are exponents. We'll get into some more difficult problems in a moment. Just want to really make sure you guys understand the basics and the principles and concepts behind this. Well, we can put numbers here, but what if I want to put a different number? What if I want to put something crazy like x to the 0? What does that mean? It actually equals 1. And I have what I think is a really fun way of explaining this, and it is not my way of explaining this. I did not come up with this. Someone who teaches math, who's probably way smarter than me, thought of this as a good way to help explain it. But we know, let's start with x cubed, right? We said this is x times x times x. We know x squared is x times x. We know x to the 1st, right? That's just the identity here, just equals x, right? That can be, this is technically something they teach, is the identity, right? Exponent identity. X to the 1st is just x, right? We just, similar to when we have square roots, we don't put a 2 in there, right? Because it's given, right? It's known that it's just the square root. This is known to just be x to the 1st. Now, x to the 0, I'm gonna leave it, right? And I'm gonna actually give you negative numbers. And let's do a side tangent here just so I can explain how to do these as well. If I have, another one up here, x to the negative 2nd, the same way I explained this, go ahead and look at this real quick and tell me what you think happens as I step through this. As I go from x to the 3rd to x to the 2nd, x cubed, x squared, I'm dividing by x. Same thing here. I'm dividing by x. So for every time I subtract this, I'm really dividing by x. It comes from the quotient rule, right? Well, I'm doing it again, and I divide by x, and I have x divided by x equals 1. Okay, well, let's keep going down, right, to solve for that up there. I have x to the negative 1. Well, let's keep the pattern going. I'm dividing by x. So this is actually just 1 over x. What about the next one? Same principle, divide by x, and I have 1 over x squared. Again, this is just going to give us 1 over x cubed. So, going back to this, that's the first time I've done it, but I just hit the mic, Levi. Oh my gosh, I'm so sorry. Oh man, I guess it's bound to happen.
That's what that means.
That means I miss you?
Yeah.
Great. So this next one, right, we've done this, it's going to be 1 over x squared. The way I like to think about this is you just flip it and change the sign. So x to the negative 2nd is 1 over x squared. You just flip it. And thinking about it as the quotient rule, where it's going to be, if I took x squared times x to the negative 2, that should equal 1. Because that is going to be x squared over x squared, which is x to the 0 or 1. Simple enough? Maybe not. Let's see. We did the identity, the 0. We have not done the last one here. So the power rule. So this is fine. Let's take this one more step, right? If any of you are in calculus, you're going to go another step up. Let's make this inception. All right, we're gonna go one step outside. Instead of digging into the dreams, we're going to go out here. We started in limbo, right? So we have x squared cubed. All right, this is the power rule. What do I do now? What does this mean? All right. Well, I know that this evaluates to x squared 3 times, right? If I have 6 cubed, I'm going to get 6 times 6 times 6. If I have 3 cubed, I'm going to get 3 times 3 times 3. So I'm getting x squared times x squared times x squared. That's what this is. That's what that directly goes to. Well, now I just use the power rule, sorry, not the power rule, the product rule, and I add these. So now I have x to the 2 plus 2 plus 2, or x to the 6th power. This is not a coincidence. That equals x to the 2 times 3. So you multiply these exponents. And this is why. These steps right here are why you multiply them. If you have any questions, let me know. Otherwise, we're going to jump into some questions that use this. And honestly, we're kind of throwing you into the deep end with some of these problems we're going over. So stop me now, or else it's going to be bad. There's no lifeguards on duty. Did you like that, Levi?
Yes, I did.
I don't think you were paying attention.
I wasn't paying attention.
Jeff wants a JP? Oh, man. Wait a minute. Hold on. How old? No. There's no way. Kylie's probably not in high school.
Kylie's in high school.
No, there's...
Josh. Dude.
Yeah, no, there's no way. But hey,
college.
when she is, this is free, Jeff. Good to see you, JP. Man, it's been a while. That was my old youth pastor, man.
That was my old youth pastor.
Definitely not.
Right.
His name was also Pastor Jeff.
Yes.
So it didn't work with like my dad, Pastor Jeff. So they called him JP instead of PJ. They just put it seriously. That's what we were really, really imaginative. Okay.
I like that actually.
Yeah, no, it stuck. I still think of him as JP. His name's Jeff, but come on.
That's really funny. It's really funny.
The JP?
Yeah.
Yeah. It also sounds better than PJ.
Yeah.
No
Why
offense.
not Pastor Jeff and then Dad?
I could say that. She's a sophomore? Oh, perfect. Well, she can start. A lot of this is, if at the very least, it's going to be good practice. A lot of the stuff we cover are things she's probably learning in class right now. So send her over. It's free. All right, some of the more complicated problems here. I'll keep this up so they know, for exponents. Now, if you've read the title, you might have a hint as to what we're going to do here, but it's called a change of base. So a sample problem you might get would be, there's one on the test. Levi, can you look it up? I think it's like 3x minus y.
Yeah.
Actually,
on this one?
Discord, please, Robot Dancer.
Nice. Robot Dancer.
So they might give you something. There's a problem that I'm remembering that says 3x minus y equals 12. And then what they actually give you over here to evaluate is 8x over 2 to the y. Sorry, 8 to the x over 2 to the y. Well, what can we do? We've talked about a number of things, right? All these rules I've given us, all the things I've talked about here. What can we do? What should we do? Well, something that you might notice right now is that 8 and 2 are different. And you might be asking, does that matter? And the answer is yes, it does. So when I had all those rules up here a minute ago, something that was the same for all of them was what we're going to call the base, right? The value or the variable or the number that was being raised to a power. For me to do any of those operations we had talked about, they have to be the same. Meaning, I can't do anything right now. I need to have the 2 and the 8 be the same value. What I can't do is I can't just say, well, 8 divided by 4 equals 2. The reason I can't do that, there you go, Robot Dancer. Congrats. That is right. I will get to that. But you can't just do that because you have it to a power. Quick example of that is, what if I had 3 cubed and I wanted to divide that by 3? All right? So that actually equals 27. But if I just divided it by 3, and again, this is incorrect. Let me do this. If I divided this by 3, I'd get 1 cubed, right? Instead of 9, right? If I divide it by 3. This is wrong. This is right. So I can't just divide it. So the easy option is out. Now what do we do? Well, I'm going to go ahead and erase this. The more familiar you get with exponents, the easier it'll be to see what I'm about to show you. And the more second nature it'll become. But I can raise 2 to a power to get to 8. And what I mean by that is there's a relationship in terms of exponents between 2 and 8. So 2 cubed equals 8. All right, so 2 times 2 times 2 is 2, 4, 8. Right? I can use this. I want to replace 8 over here with 2 cubed. So I'm going to. I'm going to get 2 cubed. Now I need to make sure I do this right and keep my parentheses where they need to go. I have 2 cubed to the x power, and we don't know what value that is, but we're going to keep it out there, over 2 to the y. Bottom stays the same, right? I want to make sure that I keep the bases the same or make them the same. I could have changed 2 to 8, and I could have said it was 8 to the 1/3. But we did with fractions yesterday, and they can get pretty messy, so I don't want to worry about it. We're ignoring that. It makes this a little bit more difficult than it needs to be, and with the values they gave you at the beginning, you'll see in a second, it's easier to do it this way, not having to deal with the extra fractions. What does this end up going towards? Right? What does this equal? Well, we know because of the power rule that I can multiply these. So I get 2 to the 3x over 2 to the y. Did you do that on my computer, by the way?
Yeah, sure.
Dope.
Yeah.
Thank you. All right. Now they're the same base. So what can I do? If I am dividing powers from one another, we've been using it to where it's all numerical values, but right now they're not. They are some variable. They still represent a number or numerical value, but for right now they're just variables. So can I still do the same thing I would do? The answer is yes. You can still use the quotient rule. So what you get over here is 2 to the 3x minus y. Right? I can still do that. It's still the quotient rule. I'm taking the top exponent and subtracting the exponent from the denominator, and I get that. Conveniently, 3x minus y, we know that that equals 12. And like Robot Dancer said 3 minutes ago, Speedy Gonzalez over here, this converts to 2 to the 12. And that's your answer. All right. Have you checked out Robot Dancer's question?
Yeah.
Is it math related?
It is math related. It is the Celsius Fahrenheit SAT question.
Oh, okay. Well, we will do it after this then.
Yeah.
Are there any questions on this? Anything that is confusing? You'll see this, I would say, probably once a test. Levi on the SAT is usually how often it might come up. But if you can do this, you can do most things with exponents, and pretty much everything they'll ask you to do on the SAT or ACT.
Yeah.
Especially if you were here yesterday and you saw us talking about logs and logarithms. Those are the same thing. I said and, but just another way of saying it. Logarithms yesterday. Logarithms are mostly covered on the ACT, but it's a good intro into this, and they kind of build off each other. Again, just another quick example, and then we'll move into Robot Dancer's question, and then Levi will come up to talk about concision. You could have had 9 to the x over 27 to the y. Now this one's a little more complicated, all right, and that's why I didn't start with it. I can't just go from 27 down to 9, and I can't just go from 9 to 27. What I can do is find a common base between them, all right, and I know that 9, conveniently, maybe not, equals 3 squared, and 27 equals 3 cubed. There we go. I can now replace these, and I get, or substitute, I get 3 squared to the x over 3 cubed to the y, which just equals 3 to the 2x over 3 to the 3y, or 3 to the 2x minus 3y. Right, once you've seen this a couple of times and you start to figure out the pattern, or you start to recognize what they're asking you to do, it becomes much simpler to break it down. Right? Any individual step here, as long as you were following along and paying attention when we went over the exponent rules to begin with, each individual step is not difficult, but being able to recognize and see that this is what they're asking you to do can be. But yeah, this is the most difficult exponent question I've seen on any of the SATs or ACTs. Great.
I'm going to pull up Robot Dancer's question, or I have it. So Robot Dancer, He actually asked 2 questions. I'm just
okay.
going to do the first one. So we have, oh shoot, does it start with a C? Yes, it does. Okay. We have Celsius equals 5/9 Fahrenheit minus 32. And then we want to see, okay, so we got this, Fahrenheit, Celsius, that's obvious. Robot Dancer, do you want to clarify what specifically was challenging here for you?
Yeah.
Because we have the 3 answers, or the 3 options. So we have a temperature increase of 1 degree Fahrenheit is equivalent to a temperature... okay, so if Fahrenheit goes up by 1, then that leads to
Wording
Celsius,
and
got it, goes up by 5/9 of a degree. Okay. Yeah, this is the way we interpret this, yeah.
Maybe.
The way we interpret it is our question type, which is equation interpretation, or interpreting equations. That's what we're doing here.
You made that way worse
Because
than it
I
needed
said
to be.
interpreting before.
The way we
in the
label
sentence.
this type of question is an interpretation question. An equation interpretation question.
Stupid.
You got it.
Okay. So So the blurb up top is just saying it relates this thing to this thing. So we know this is the equation that relates Celsius and Fahrenheit. And then number 1 says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of a degree Celsius. Okay. There are a couple ways we can do this. We say, well, if Fahrenheit goes up by 1, that means that Celsius has to go up by 5/9. You can do this the brute force way, which is saying, okay, well, I'm going to pick some degrees and see. So let's say that F equals 0 degrees. Then we know at the same time, if F equals 0 degrees, then we have negative 32 times 5/9. So C equals, we'll do it this way, negative 32 times 5/9 degrees. That's what Celsius is. Does this make sense so far? I just picked a random coordinate pair for that relationship. And then I'm going to say, well, to see if this relationship is true, I'm going to add one.
JP. Thanks for the share, JP.
Thank you for the share. Now I'm going to add 1 degree to the Fahrenheit and see what happens to Celsius. So if Fahrenheit now equals 1 degree, then Celsius, if we plug it in, we have 1 minus 32, which is negative 31. So Celsius equals negative 31 times 5/9 again. And this actually does make sense. It's harder, but if you actually plug this in, the difference will be 5/9. You're doing 5/9 negative 31 times versus 5/9 negative 32 times. So we have 1 less negative 5/9 here. Does that make sense, Robot Dancer? This is actually, in this case, a harder way to say it. You know what? I'll do this. Oh, where's the calculator? Oh, here it is. Okay. So if I'm going to, it probably would just be way better if I did this with the calculator. So we have 32 times 5 divided by 9 equals negative 17.78. And then this one is, oops. Last. Really? That doesn't let me go back?
No, it's an old school calculator. How dare you?
Negative 17.22.
You can delete things.
And now,
one backspace.
From here, what is 5 divided by 9? 5 divided by 9 is 0.5555. So that is the difference between those two numbers. That's a messy way to show it. The way I like more that actually demonstrates a fuller understanding of this concept is we're going to rewrite this in y equals mx plus b form. So we have 5/9 f minus whatever this is. So 32 over 5/9. Oh, well, we actually know it's minus 17.78. 17.78. Okay? Now, from here, it's very easy to tell. This is the definition of slope. If we say that the Fahrenheit goes up by 1, that means that Celsius goes up by 5/9? Yes, because 5/9 is the slope. So anytime you have this thing, right, the slope here is 1 unit going from there to there, and then whatever the slope is, you go up that high. I couldn't use a calc. That was no calc section. Yeah, that's okay. So you don't necessarily have to. I put these in decimals because I thought that might help. It clearly didn't. So I would have actually kept these as fractions. You could put this as, if you're doing the subtraction here, you can pull out the 5/9 and find the difference like that. And this is the easier way. So we can leave this as whatever it is, 32 times 5/9. So we have 32 times 5 over, that looks like, do it this way, divided by 9. You can have it like that. It doesn't matter. That's just your y-intercept value, but the slope is what matters. So yeah, good. The slope helped. That is the most important thing here. So that is why number 1 is correct. And then Roman numeral 2 is slightly different. Roman numeral 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Okay, so this is saying, so we know this is true. Great. And now this one is saying 1 degree Celsius, I don't know why I looked at the calculator for that.
Yay.
Yeah. Means an increase of 1.8 degrees Celsius. Okay, we can do the same thing here. So you plug in, we can't use this, we'd have to plug in 1 for C, or, and so you plug in 2 different values, changing the Celsius by 1 degree. Or you can rewrite this equation so that it's in y equals mx plus b form, but you have f equals something. So in that case, we'd come over here and we'd multiply by 9/5. So we have 9 over 5 c equals f minus 32. This actually looks even prettier. And we'll add 32 to both sides, and then I'm going to flip it around. So now we have f equals 9/5 c plus 32. From here, it's much clearer. If we add 1 degree Celsius, that means we're figuring out exactly what the slope is. The slope is 9/5. 9/5 is 1.8. If you divide 9 by 5, you will get 1.8. And you do need to be able to do that type of math without a calculator, for sure. Does that explanation for this one make sense? Generally, when they give you an equation, you are either going to be solving the equation, of course, or interpreting the meaning of the equation. Almost always one of those two things. Number 3, a temperature increase. Can you explain the 1.8? Yeah, so it's the same thing. So we have this equation, which is the same as this equation. And for this one, we said that the Fahrenheit goes up by 1. Or no, sorry. Oh. This one. This is in y equals mx plus b. So for this one, we raise Fahrenheit by 1, and just by the definition of slope, we get that the Celsius goes up by 5/9. And that's clearer here. But now if we go Celsius up by 1, we'll use this equation, and therefore Fahrenheit will go up by 9/5. 9/5 equals 1.8. You will. So what's hard about this question is it doesn't say 9/5, and you go, oh, I can just do the reciprocal. You have to be able. It doesn't show you the path as clearly, unfortunately. So that's why that's one of the reasons why this question is hard. Okay, and now the last question, or last option, is a temperature increase of 5/9 Fahrenheit. So if we're doing Fahrenheit up by 5/9 of a degree, is equivalent to a temperature increase of 1 degree Celsius. Celsius goes up by 1 degree. This you can figure out to be wrong a couple of ways. You can say, well, these are the same thing. It's just an equation. As if it varies one direction, it'll vary the other way. So these are the same, but we know that this is 9/5. So for a 1 degree Celsius change, we need a 1.8 or 9/5 change in Fahrenheit, and therefore we don't have that. This is the wrong number here. You can do it that way, or you can figure it out. Say 1 degree Celsius change, well, it's 9/5. Or you can plug in numbers like we did at the very beginning. Lots of ways to do it. But this is definitely a very confusing question, for sure. Have you looked at Robot Dancer's second question?
What? No, but I can do that real quick. Third question?
Oh, there are 3?
Ooh, I like this one. Never mind, I know this one.
Cool.
Oh, this is a fun one.
Do they have a third question?
It may just be answer choices. No, it looks like a whole other question.
Cool. Hey, Robot Dancer. Also, how are you? How's life going?
Oh, how did that test go last night? Did you fill out the form to see what things you needed to work on? Did you take our thing?
If you couldn't hear that, Brendan's asking about if you were able to get to the diagnostic we did, or if you could find the answers from when you took that test previously.
It'll help you figure out what questions give you trouble, what question types, and then you know what to study for and what to ask us, so that we can teach you. Sorry. Okay, this next question, that's enough space to start. Actually, I'm going to switch it because I have to draw something large.
Sure. Is it a circle? I didn't have time, but I took practice test 3 and got 750 on math. Ooh, nice. Very nice. Very, very nice.
Oh, that's the one where every answer is just A, right? So you just kind of guess on that one.
Yeah.
Yeah, okay, cool.
Very much so.
No. All right, so we have these lines. Come on, Brendan, don't mess this up.
You got it.
Yes! Okay, come on, though, Levi. That actually looks pretty good.
Oh, yeah. Ooh, yeah, this one. This is cool.
And L is in cursive, so you know it's not I. I don't know, guys. All right. So we have all these values. X degrees. Is that easy enough to read? Yeah, I'll make sure they're a little larger. Y degrees. Z degrees. T. U. And V. Let's round that. No. All right, good enough. Okay. They're saying that we know X plus Y equals U plus W. Where's W? It's not a V. Thank you. That would make this problem quite impossible. All right. What do we do here? We know this, and we know they all cross at the same point. Right? This is one big dot that I, honestly, guys, pretty impressively was able to get first try. So if you're just now joining, you missed one of the greatest feats of today, of man today. All right. Mankind as a total. So we have these things here, right? We're trying to say which of these do we know to be true? All right, we've all seen these questions, or you haven't, and if not, go ahead and ask. But we have X equals Z, Y equals W, and Z equals T. That's everything I need here. Let's go ahead and figure some things out, though. What do I know is and isn't true? What do I know to be true? What do I know to be false? Well, I'm going to write down all... So this is our given. And then over here, I'm going to say our known. All right, because you can figure the rest of this out, right? Here's our known things. They gave us this, everything over there. What I know, though, is that W equals Z, because they're opposite one another. X equals T, and Y equals U. That may or may not come into play, but we'll see. So these are the things that I know for sure true based on the fact that they are opposite angles. Great. If you have any questions, we have a video where I explain all the angle things, all the things angles on YouTube, and it's fast forwarded pretty much through all of my normal things like this where I talk and I don't get to the actual problem, so you don't have to worry about that. Okay, now does X equal Z? I don't know. As I look at this, I don't know. Y equal W, for my known right now, I can't prove that. And my last one is Z equals T. I also cannot prove that from my known. But let's go ahead and tear apart this given real quick. What can I do here? Well, I have X plus Y equals U plus W. But if I look at this, I notice that Y equals U. All right, so this right here goes right there. So really, we're saying X plus 2 equals 2 plus W, or really whatever. But that means I now know that X equals W. Are you guys following along, Robot Dancer specifically, since this was your question? But if not, let me know. But does it make sense why this is true? X equals W, just from this. All right. Not following. Okay. Which part is confusing? So the first part here, how did you make an equation? This is given to us in the problem. Or are you saying over here? This is given to us in the top of the problem in the actual text. And then over here, I know, because they're opposite one another, that these angles are all equal to each other, congruent, if you will, right? Does that make sense, Robot Dancer? So x equals t, z equals w, and y equals u. We know that for a fact just because of what they've said in the equation, or what they've said in the problem, and how they've drawn it. From that point, I take that y equals u and y equals u over here, and I can replace them. So really, I can say that, you know, if you want me to draw this out, so y equals u equals makes that. Yes, so let me go ahead and draw that out here. I'm going to plug in y for u. So I have x plus y equals y plus w. Right? Because u equals y. Now I subtract y. They both cancel, and I get x equals w. Does that make more sense, Robot Dancer? I guess I skipped a couple steps there, but hopefully that clears it up right here. Yes, great. Okay, moving on. So the first thing we know is x equals w. Now let's run back through what we know and see if that helps at all. All right? So if I know this, I'm going to go ahead and put blocks here. So we know that this is what we started with. We were then able to solve for this, right? This is what the first thing we knew. Now, here's the second bit. What can we get from here? Well, x equals w. If x equals w, w equals z, so x equals z. Which means this is good. Now, I did that kind of quickly. So x equals t, w equals z. If x equals w and w equals z, then I can just say, I can replace them, right? I can substitute them. Still making sense? Stop me if it doesn't. All right, so I know that. What else does this say? Well, x equals t. Do we have anything with t? Yeah. If x equals t and x equals z, then we also know that z equals t. So I like that. So far, so good? Okay. If not, say something as you have. Anyone else, if you're confused on this, let me know. But so far, this is where we're at. The last thing we want to try to prove is that y, you think you ignored the equation? That's probably not a good thing. Don't do that. You didn't know it mattered so much. There is very rarely a time in math they will give you an equation or they will give you something as a given, right, that is not useful. Occasionally in long word problems, they might say things that don't matter. But in something like this where it's so concise, I would say this is very important to remember, very important to use that.
The SAT is about equations. It is more about equations than anything else, more so than the ACT, more so than the rest of your life, most likely.
Ouch. Yeah.
No, truly though.
No, yeah,
like,
I know. I'm just kidding. Yeah. So right now, what we know, based on this, all these things are the knowns, right? So z equals t. So this is the same as this. This is the same as this. I still don't have any connection. Thank you for following, Monica Lone. Monica Lone. Or Mon Icalone. Thank you for following Monica Lone. We appreciate it. I don't know who you are, but please ask your questions, get your answers, and ace the test. Because that's how kids say it nowadays. Ace the test.
Yeah, they always say ace the test. So
ace the test.
Yeah.
Okay, from here, what we know is this, right? We have w is z, x is t, x is w, which means now z and t equal each other, right? We've got all that. But from here, nothing we have connects y and u to anything else, right? And I pretty much expanded as much as I could, and I've exhausted all of my resources. And because these are secluded here, I don't know that it reaches out to the other ones. For some reason, when I remember this equation, I thought it was all true, but I think it's not. I believe this is where I am now stuck. So I cannot prove that y equals w, right? Levi, if you want to double check me on this, but I am very confident that this is where we're at. So Robot Dancer, you know the answer. You can double check me on that. Go ahead and tell me I'm wrong if I am, but I'm pretty sure I got this in my back pocket.
Very nice.
I don't have back pockets because they're shorts.
Are you done? Because one, I'm very excited to do concision, and
just make it quick.
I'm just wondering. Stop it.
That's what you call a knee slapper.
Stop it.
Okay.
That is
Great. There you go. At this point, the reason I can cross out this is because this is all the things I know. There is nothing connecting Y and U to anything else. And so at that point, I know I cannot connect it to anything else. If that wave emoji. Hey, CB Turtle.
CB Turtle, hello.
But great. Robot Dancer, let me know if that is confusing, and we can cover it. Or you can just go check out the link with the... you can check out our YouTube channel and check out our video with all the angles if that was something that confused you. Or anyone watching. Our YouTube channel is linked on all of our sites. And if you're watching on YouTube, feel free to either right now or after, if you know angles are an issue for you, go check it out.
Yes, also...
I am not Brady. How dare you say that about me?
That's embarrassing. Just so you know, I shared on Facebook the Ridgewood Moms and Dads group.
Oh, cool.
If you are watching on Facebook and you're from
you still spelled it wrong.
The Ridgewood Moms
Robot
and Dads
Dancer.
group, say hi. You can ask some questions. We'll see you in the chat. And if you are a student and want to ask questions, you can click on the Discord link, which allows you to post screenshots of SAT or ACT questions that you can't figure out on your own. You want us to go through them on the board.
But if they're general questions, go ahead and put them in the chat, put them in the comments below. We can answer those.
Yes.
So keep them coming.
Robot Dancer, we will get to your third question, but I want to do concision first, and then we will get to that question.
It's AN, BRENDAN, Robot Dancer. It's literally in the description below.
Yes, it is.
You're not even trying, and it hurts. Okay.
Come on, there we go. Okay. We may lag a little bit.
Yeah, I'll do that.
Oh, yeah. I need to go to number 18, please.
On
the English, yeah. Ooh, what's going on?
Took a minute. Okay, 18 English.
18 on the English, yeah.
Boom.
Very nice. Okay, we are doing concision. Concision is,
cool.
in my opinion, it's a sleeper. It's a sleeper, I think. So this is redundancy often. Is what you're dealing with. This is the negative of it. Redundancy, you want to be concise. I think conciseness is also a word. Okay, number 18. We have, if we're just, so I always say read the answer choices first, because if you read the answer choices first, you might have a good idea of what the question type is, what they're testing you on. Once you do that, then you can recognize the approach you're supposed to take. It allows you to save time because you have only 45 minutes to do 75 questions. So we have, even though we used our walking sticks, despite any efforts to remain steady and with each step. I'm not even going to read what the no change is in here yet, although I really should underline it because that's not showing up for me at least with our walking stick. What is underlined here? I think it's
something with jumbled rocks.
Yeah, somewhere there. Okay. What you need to notice about this question type is it's not messing with commas, it's not messing with any other type of punctuation, it's messing with actual information. These lack information that's in the other. We have with each step, and then even though we used our walking sticks. This will deal with concision and or ambiguity, because there is information lacking in some of the answer choices. That doesn't mean that we pick, people say you always pick the shortest one. No. Don't do that. There are several steps before you just pick the shortest one. So what we need to do is read what's above it and see if our information is all necessary. Okay? So I'm going to read starting at the top with we. We tried to steady ourselves with our walking sticks, but slipped and stumbled because of the jumbled rocks we were slipping on. Okay, so that's the given one. I don't like this because we have slipping right here, but we also have we slipped and stumbled. So that's repetitive. It's redundant. So F is wrong for that reason.
Boom, roasted.
It's very roasted.
I want to get that soundtrack of Michael Scott saying that, just so we can, every time we cross one out, have that.
We could also have a that was easy button, that type of thing.
Yeah.
Maybe just a bop it. Just
bop
make
it?
random noises. Yeah.
Twist it!
Yeah, exactly. Okay. Get a soundboard. Yes, we should get a soundboard.
Absolutely.
CB Turtle, get on it. And we will get that soundboard.
If anyone wants to donate one, we'll take it. We'll gladly take it.
We'll take it, yeah. Okay. We have G now, even though we used our walking stick. So this is something I noticed the first time I read it through. We tried to steady ourselves with our walking sticks, but we slipped and stumbled because even though we used our walking sticks, so that doesn't make any sense. We're doubling up again. So I don't like G.
And it's the underlying portion is all the way to the period.
It is all the way to the end? Okay. That makes a little more sense. Oh boy, sorry. Okay.
And I think it goes all the way to because.
Wow, that's just horrifying.
I think
it's just the whole line.
I think it is because
okay.
And stumbled with each step and stumbled despite any efforts and stumbled.
Okay, so it's the whole line. There we go. That's what we're trying to replace.
Show up for ours.
Yeah. Last two. H. Despite any efforts to remain steady. Okay. But right at the very beginning we have we tried to steady ourselves, but slipped and stumbled despite any efforts to remain steady. No. Don't say it twice. There's no point. That means the big dog is big. That's not helpful. Unless it's Clifford, and then maybe you want to repeat that. Do you remember Clifford?
Clifford the big red dog?
Yeah.
Yeah, no, I remember Clifford.
Okay.
I don't remember any of the people's names for some reason, but
yeah.
Definitely remember Clifford.
Okay, and then we have J with each step. Yes. Okay, because they're not talking about we took each step and then they say it again. We tried to steady ourselves with our walking sticks, but slipped and stumbled with each step. That's fine. Now, although I said don't always go with this shortest answer, in this case it is the shortest answer, but that's fine. And I will show you, I think one of the next two will demonstrate that it's not always the shortest answer. Okay, if you have any questions on number 18, please let me know. Send a bunch of exclamation points or something like that. But otherwise, let's move on to number 41.
Yes, sir. Oh. Nice.
So while this is on the ACT...
Oh, yeah, never mind.
It's not quite.
Underlined the line. It just wasn't the right line.
Okay. Now, I'm telling you which ones we're doing, and obviously they're going to be these concision redundancy questions, but we'll check again, see if it fits our mold. So number 41, we have people creating art now, potters and Mata Ortiz, or delete.
Hold on.
Yes.
Tell me it doesn't sound like a weird, creepy advert. People creating art now. Like that's how I.
For you today.
Exactly. Sorry, guys. I just couldn't.
Just call this number.
You just read that without any context. And people creating art now. That's on the subway, just
that's
everywhere.
So vague.
You too can be a people creating art. Yeah. All right, I'm out. Holy crap!
Can you give me a prettier marker? Because this one is on its last legs.
Both of those were prettier.
They are prettier, but not the catch. Okay.
Ha 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 ha! They're pretty, but not a catch. I thought that's what you said. That's not what you said?
You have so much energy right now, Brendan. Oh my gosh. You gotta work more hours. That's what you gotta do.
No, honestly though, that might be it. I only worked 8 instead
exactly,
of 12.
Yeah, that's what I'm saying. You should have worked 12
now.
today. Anyway, number 41. We have just delete the whole thing entirely, but it's not a transition word or not. It's actual information. We have people creating art now, and then we have potters, which is way more specific in Mata Ortiz, which is a place just in the context of this passage. And then here, which is the given, we have potters around, which has potters, but then around is pretty vague. So this is a concision question or ambiguity. So let's see. I'm going to start at the beginning of the paragraph. Quezada helped his village with the money he earned selling pottery, but he wanted to do more. So he taught people from Mata Ortiz to make pots. Today, there are more than 400 potters around, all of whom make their pots by hand. Great. So the sentence is, today, there are more than 400 potters around, all of whom make their pots by hand. I don't like around. I have a problem with this word. It's informal. So this is a concision question, but there's an answer choice that you can eliminate because it's informal. This is a pretty formal essay. Generally, you want to stay in the formal to very formal tone.
Or voice.
Tone, voice, formality, style. Yeah.
All these things.
All of those things. So I don't like 41 very much, so I'm going to cross out A. And then we have B, which is people creating art now, which you really like. So let's read that again.
It's ridiculous.
Today, there are more than 400 people creating art now. All of whom, yeah, okay. So this one is...
Keyword. What is it? What's the key word?
The key...
What's the key word there? What's the word that throws it off?
Are you talking about in the answer choice B?
In the actual
I don't like... Also, basically all of these words.
Now.
I think people is too vague. Why don't you say Mata Ortiz people? Why don't you say potters? And then also now. It introduces time, which is too... It's not too specific. It's just irrelevant to everything else around this.
No, It's not irrelevant. It's repetitive. They said today.
Oh, now. Oh, yes. That's a tricky one. Yes. So we have today here, and then we have now. That is redundant. So that's the redundancy problem for B. So we don't like B.
Sorry, I'll stop distracting you.
No, that was helpful. That's good.
I thought me talking probably.
And then that's very true.
Yeah.
And then we have C, which is Potters and Mata Ortiz. So let's read this sentence. By itself, it actually sounds fine. Today, there are more than 400 Potters and Mata Ortiz, who all of whom make their pots by hand. That sounds good, but it's not in this sentence that it's redundant. It's actually with the previous sentence. So he taught people from Mata Ortiz to make pots. Today, there are more than 400... Oh, actually, comparing it to D... So it seems a little repetitive because we say Mata Ortiz, we say Potters, and it's the second time we've said that. But we know for a fact that we don't want to say now. We know for a fact around is not the correct tone. And then D is deleting them. So this is why you want to go through all four answers. You don't want to say, well, I didn't like C very much, so I'm just going to pick D and move on, and not even read D. Reading D, we have to delete this whole thing, which means today there are more than 400. 400 what? If it's very clear, you don't have to say what the things are, but it's actually ambiguous because we have, so he taught people from Mata Ortiz to make pots. Today there are more than 400. Pots or potters? 400, all of whom make their pots by hand. It's a little vague. We aren't sure if we're talking about pots or potters or maybe something else, but those are the two things in the previous sentence. So I don't like D. I think C is best. It does repeat itself. But in order of importance, we have, I'm going to write this over here. Number 1 is clarity. I'll get to that in a second. Number 2 is concision, which is what we've been talking about today. And number 3 is formality, tone. Now, a correct answer will have all of these things, and they will all be correct. But the order in which you are pursuing them is clarity first, concision second, formality and tone third. So while I think that C isn't particularly concise, it's way clearer than D, which is way more concise because you just don't say the words, but doesn't make any sense. Does anybody have any questions on that?
I want to hear from our singular YouTube viewer. We have someone on YouTube right now.
We have somebody on YouTube.
Thank you.
Yeah.
YouTube is our least watched.
YouTube is fun. Okay, number 52 is the last one, and then we can open up to general questions about the SAT, ACT, college application process, although that's pretty far away for most people. If you've gotten into college and you're one of our viewers, then let us know. You know, that'll be fine. You know, ask about Brendan's personal life.
Or not.
Or don't ask about Brendan's personal life, but you should.
No.
Can you go to number 52, please, Sarah? Thank you.
I guess.
Okay, number 52. I'm going to need this.
I think it's just gray building is the underlined portion. Or the
cool.
gray building. Yeah, the gray building.
Just gray building, okay.
Incorrect. It's just gray.
Oh, there you go. Adam B., you're on YouTube. What's up? You are the YouTube viewer. YouTube is
cool with those glasses.
Very cool. So for those of you who are on Facebook or Twitch or YouTube, whatever it is, you just can't see other people chatting on the other platforms, unfortunately. But we can. So we'll tell you what they say. Adam said YouTube, from YouTube, and had sunglasses. Very good. Do number 52. Okay. Adam, if you have any questions, follow the link to the Discord. Put screenshots of stuff in there.
Or just comment with the question.
Yeah, unless you have kids who are of SAT, ACT taking age, or parents of SAT or ACT taking age. You know, all of the above.
Cousins. Don't forget those people.
Yes, acquaintances. Okay, we have gray limestone, delete. This is a concision question because gray is added in G, and then there's nothing in J, and then the no change one is just gray.
Yep.
So we're just saying gray. Okay. So what we're doing, this is actually a very straightforward one, the most straightforward one of the night. Gray and limestone. Those are the things we're looking for here. So let's start. This is a long sentence.
I thought gray was with an E, and it's both.
It's both.
I didn't know that's the UK preferred. Most of the
Oh,
books I
is
read
it?
when I was younger must have been more UK because I thought
Yeah.
theater was RE, and I thought like there's a lot of things that
Yeah.
really messed me up for spelling quizzes.
I've actually started telling my students that to help them with the old English passages, if you like fantasy novels,
Yeah,
then that helps. BBL. Got it. I don't know what that means.
Well, it's not Brendan's personal life.
No, it's not.
So
Brendan,
right.
you may be trying to say BPL, which is Brendan's personal life. CV Turtle. I'm not sure what BBL is, unless that's. No, I don't.
All right,
I don't
52.
know. 52. Gray and limestone. Okay, immediately I see gray limestone up here, so let's keep that in mind. Be back later. Oh, yes, very good. Yep, see you tomorrow.
That's a thing.
Night.
See ya.
Sorry that we didn't understand that. We're old. So let's just make sure that this actually matters here. Oh, this is a long sentence. Okay, I'll read the whole paragraph. Demonstrating the Beaux Arts infusion of Renaissance and Baroque details. Tall, arched French windows symmetrically placed between the columns lighten the imposing gray limestone structure.
Wow.
I could have read that better. I just didn't know what the verb was.
Riveting.
Above the windows and frieze, an exterior balcony spans the width of the gray building, or the gray limestone building. Okay, we're talking about the building. We're trying to figure out what adjectives we want to use to describe it. Do we want to use none, gray, limestone, or gray limestone? I think we want to use none. We're not ambiguous about what's going on. We're still talking about the building. There's no other building we could be confusing, right? And it's not asking us, do we want to put building in there or not? If they asked us building versus it would probably be a good idea to use the word building, but we have that. So the answer is J, delete. Questions on that, let us know. We will answer those questions. Otherwise, we are done with the lecture part. We can talk about any other questions you may have.
Yeah, Robot's got another question.
And Robot's answer has multiple more or just that one more?
Well, they're not sending us the entire question.
It's barely cut off. I think it's fine. You just need
Each student 3 milliliters. You have 5 left over.
Oh, I like this question. Can you pull off?
Yeah.
Can you take off the overlay and then I'll do this
I mean,
one?
I guess I could.
Thank you, sir. This is fun. Okay. So for those of you who don't know where this question is, it's in the Discord. You can see other people's questions there. It's ideal to go there. But I will write up the important information from this question.
It's also free.
It's all, yeah, everything is free.
Also,
Everything is free.
how often do we do this, Levi?
Hey, we do this from 8 to 9:30 p.m., 5 nights a week, Sunday through Thursday. And then the nights, the week leading up to the actual SAT date or the ACT date, we do it on Friday night as well. We go a little bit longer. We stick more to talking about more fun topics and then also how to deal with the stress and the food and should you play video games that night. Do whatever.
But it's also in Eastern time, if that wasn't clear.
It is in Eastern time.
So we're kind of in the future.
Okay, so if we give 3 ml to each student, we have 5 ml left over. Okay, so that's situation 1. And then we have giving 4 milliliters to everyone, he will need 21 more. So 4 ml to each, need 21 more. Okay. How many students are in the class? That's the question. How many students are in the class? Hopefully that's enough information for those of you who haven't read the question. There's a classroom, teacher's giving them stuff or the other stuff, and then we can figure out how many students there are. Okay. Building equations. That's what this test is all about. Yes, Robot Dancer, say it with me. Building equations. Very unlikely you actually said that with me. But that's fine.
There's a delay.
I will, yeah, so maybe they did. I'm just saying when sound got there. Okay. We're going to build an equation. There's going to be an equal sign. I wonder if we can make this a system of equations.
Yeah.
You could, feasibly. You know what? That actually might be the clearer way to do this.
That's what I was thinking of.
Yeah. So let's say that there are S students.
So, slight diatribe here. The equal sign that is not yet used as an equal sign, for me, just looks like a battery or a power source from circuits.
Oh,
you
does it?
draw a line from the bottom to the top, straight from the middle of either of them, going up and then going
Like that?
down. That doesn't connect in the middle, yes. Yep. Now you have a battery or a power source.
Oh. Isn't that a breaker or something like that?
No.
I don't know what that means.
No.
Okay.
Just
We're going to say that there are S students. So that means that given S students, if we give 3 milliliters to each of them, so 3 to each student, we will have 5 left over. So I'm going to say that, this is another thing. I'm going to say there are S students and M milliliters. So we're going to say that the number of milliliters we have is equal to 3S plus 5. No, minus 5. Oh boy, minus 5. Please let me know if this doesn't make sense, but I am about to explain it. M is the number of milliliters we have. If we give 3 milliliters to each student, we're not going to we still have too many milliliters. So this is the number of milliliters that we're actually using. So we have to subtract 5 from it to get to the actual amount. That was also a bad way of explaining it. You're using 3S milliliters here, and then you take away 5 because you have 5 extra. You need to take away that extra stuff, okay? Or we could have it as M plus 5 equals 3S. Doesn't matter. This is the first equation. The second one is 4 to each, and you need 21 more. So the number of milliliters is still the same. If we give 4 milliliters to everybody, this is wrong. That's why I couldn't explain it. That's plus 5. Okay. Yeah. These are the number of milliliters we use. So if we give 3 to every student, we still have 5 more to have. But we're not giving them to anybody. That's why that was so hard to explain. And then we have 4 milliliters given to everybody, but we don't have enough. We need 21 more. So we're going to have to subtract 21 milliliters. That doesn't make sense? Please let me know. Then from here, we can solve the system of equations. We have 2 equations, and we have 2 variables, m and s. Let's use substitution because we have 2 m's here, so that's pretty simple. We're going to set them equal to each other. 3s plus 5 equals 4s minus 21. We're going to subtract 3s from both sides. And we're also going to add 21 to both sides. We have 26 equals s. Now that's the number of students, which is the question. The answer is we have 26 students. I apologize for the mistake in the middle of that robot dancer. Do you have any questions? Do you want anything clarified on this? It seems like not. Oh, why is it plus 5 if it's 5 milliliters left over? Okay, so let's, and if this ever gets confusing in your head, because this is very common, you have to build an equation out of a word problem. You pick numbers and see what makes sense. So let's say that there are 2 students. If we say there are 2 students, then that means if you give 3 milliliters to each student and there are 5 left over, that means you give out 6 milliliters, so 3, 3, and 5. So you're going to have 11 ml. That makes sense. You give 6 of it to the 2 students, you have 5 left over. And if you want to plug in these numbers here to this equation, you have 2 students, so that's going to be your 6 plus 5, and this will be your 11 here. Does that make sense? So you can do it with just using small, simple numbers and then see which one makes sense. So if you were seeing, well, does a minus work here? No, it doesn't. You're trying to figure out how many milliliters you have. So you actually have a certain number of milliliters on each side of the equation. This is just what you have, so you don't change it. And the other one is, okay, well, I have this pot of milliliters, and most of the pot is going this place, and the other part of the pot has to be added to it. That's just leftover. Does that help? Because that is confusing. Honestly, when you're building equations, plus and minus is often much more difficult than multiplication and division. And then the opposite works here. We could also say that you're giving out 3 times the number of students worth of milliliters, and that's going to be the number of milliliters you have minus 5, right? It's not going to be quite that many because you have 5 left over. And then this converts to this equation very simply. Yeah? Brendan, that was for you. I did this. Doesn't matter.
That's for Brady.
I don't even like it. Yeah, Brady's not even here.
But he'll edit it.
Okay. Does that clear it up? It is confusing. I would recommend sitting with it, maybe doing a different problem. You can make up this problem yourself. Change the numbers and see if you can reason it out again. Trying to think of a fourth or fifth way to explain.
I mean,
contextually.
if they have
Yeah.
some, I got another one. If that's still confusing, Robot Dancer, Brendan's coming on here. Hey, here we go, third
It
person.
seems fine.
If that's confusing, then I got another way to say it, but otherwise, we're all good.
What
Can I
would I
take
like?
back the good markers?
Yes. Okay. Does Robot Dancer have another question or no?
No.
No. Okay.
Now,
Okay.
very confusion.
Oh, blast.
All right, well,
Let's change all the numbers so that we're not
So-
stuck in this same place. Unless you want to.
I do kind of want to go over this real quick. So you're still confused. So let's keep this up over here. At least the students in the milliliters thing, right? I don't care about the rest of what this says, but for now, I want to use the same units, same type of stuff. So we have S for students. The wording is confusing. So the wording that we were using or the wording that they give you, right? So you have S for students and M for milliliters. Let me know which of those it is. And if it's something I'm not talking about, I'll just stop and we'll go back to it. So we know that we have 5 left over and we'll need 21 more. So if I have 5 left over, I think of that as a remainder. All right? I'm dividing out, right, these values. So I have, M milliliters, and I'm dividing it by the number of students. All right, that's how I like to think about it. Each student is getting this amount, so I'm dividing it by students, and I'm ending up with some remainder of 5 left over. Right, 3 milliliters per student, and I have a remainder of 5. So from there, let's do milliliters. There we go. It's not to be confused with M. 3 milliliters per student, right? Out of the total, I end up with 5 left over. That is my remainder, right? This mathematical equation here is not how it works for this specific equation. This is just how I want to think about it, okay? So, thinking about it that way, I have my total milliliters, right? That's going to be equal to every student getting 3 milliliters, right? With a remainder, a plus 5. Does that make it a little more clear? Does that help at all? Is it the wording that they give or how we were explaining it? Robot Dancer. This is directed specifically at you. Let us know. I don't want to be up here if you get this part just repeating it over and 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 over on concision day.
Ooh, remainder. That's actually an interesting way to explain it too.
Yeah, that's how I like to think about it.
It's good. Okay.
Yeah, and yeah, it doesn't quite work with the negative remainder, right? That means you're short something. So if you're short something, that means if you have that, you have it for every student, you're short 21, meaning you don't have all 20. You need 21 more, right? So you need 21 more, so M plus 21 would get you everything you need for those 4 students. Right? And up here, you have 3S. For everything for the students, you have M minus 5 milliliters because you have 5 left over, right? These are the same thing, right? I like thinking about it kind of like that. I like it in where the S's are on one side instead of the M, right? For 3 students, 3 milliliters per student, I need all my milliliters and then less 5 because I have 5 left over. I don't need them. Throw them out. All right, but you're good. Kemos. That means what more? If you guys have more questions, let us know. Robot Dancer, keep them coming. But yeah. Essentially, guys, we do this 5 nights a week, every week. It's free. We also have a website where you can take a free diagnostic and it'll tell you in much more detail than Khan Academy, boom, boom, shots fired, in much more detail what topics you need to cover. So it's no longer just going to say, hey, you struggle with basics of algebra or principles of algebra. It'll say what that really means is you need to work on lengthy word problems or you need to work, oh no. Or you need to work on systems of equations or exponents or, I don't know, things like that. Things of that nature. But it will tell you specifically what the issue is. Let's see what the people are saying. Can I ask a live question? Sure. I'll answer those. Come on. Holy crap. But it's school-based. Go for it, Robot Dancer.
Ask it.
How do you deal with distractions from school? Because I want to keep a social life. Well, I was not... No one would have claimed that I was the ideal student. So, how do you deal with distractions from school? Well, it's a lot different than high school because you actually have a lot more time to yourself to figure out what you want to do and to do things, right? You're not going to be in class 8 hours a day. You're going to be in class 3 hours a day for Monday, Wednesday, Friday, and then Tuesday, Thursday maybe for 4 hours. Or maybe you have Monday, Wednesday, Friday, you're doing 6 hours a day and then nothing the other 2 days. Or, whatever. You get the point. You have much, much, much more time to be distracted and it not be an issue in terms of your schoolwork. Now, there are decisions you have to make. Do you want to continue to get A's? Do you want to get B's? Do you want to get B pluses? Do you want to get A pluses? There's all these things that you have to decide, right? Because at some point you can with the TAs get some help.
No.
Oh, be friends with nerds. Yes, that was Levi's trick.
That was my trick. I just did homework with my friends.
Yeah,
and
honestly,
I just sat with them and did homework.
Lots of schools are very, very big on what's the word I'm looking for? Not combination. Working together.
Collaboration?
Thank you.
Yep.
On collaboration. And they actually, recommend that you do that. Yeah, I would say it's very easy to keep a social life. It's easier in college than it is in high school for sure.
Yes.
Much, much easier. So if it's not a big problem right now, you're fine. Now, there are some programs that are very intensive and very, very difficult. And I went through one of those, and I can promise you that I still had time to hang out with friends, be in a fraternity, and be in multiple other clubs while still maintaining a B+ average. Boom. Write home about that. I didn't write home about anything. My parents were not happy about that. But, no, I mean, it's again, and I didn't want to be an A+ student. Now, could I have? Maybe. Not an A+. No, I don't think I could have. I think that would have been required too much time. But it's just the amount of time you put into it. So you get to decide a little bit more. How much time do you want to put in? What do you want to get out of it? And it is now up to you. You are an adult. You get to decide those things in college. I've seen people go both ways. I've seen people just throw off school and then get kicked out of college, and that's not ideal. And I've seen people who live in their bedrooms, and they do get the greatest grades. But I think college, and sorry moms and dads, but I know we're doing it to the moms and dads Facebook. That's why I said that. I thought it'd be funny. Levi just freaked out. Guys, I wish you could have seen his face. No, college is an experience. You're there to learn, and you're also there to learn about yourself and grow, and not just about some given topic that you choose to study. Now, it's important, and that's why that's a big reason why you're there. But you're also there to learn and grow as a person. So I think having a social life is very, very important to getting the true college experience. Otherwise, why not just stay at home and read the books all day?
Yeah, find the fun in the learning. That's what we're trying to do with this. That's why we didn't build this with Google and then try to add a social component to it. We're doing it on social media and doing whatever you all ask us to do. And we answer those questions. I thought you were going to draw a pawn.
Oh, no, that'd have been hilarious, though.
That's what I thought you were going for. Is this the best thing you've ever drawn?
I mean, I am making sure I'm trying to do this correctly, but what you want...
One of my teachers said that SATs and ACTs are just bad tests and they aren't for everyone, and people with good grades are just memorizers, and people who are street smart will be successful, and the balance is ideal. What are your thoughts?
Well...
Okay.
Whoa, I disagree with your teacher. I disagree with your teacher, actually.
It's a very, very generalized, absolute statement. I think that, this thing, very much so. No, I don't think that people with good grades or who do well on tests are just memorizers.
Did you read that out loud for other people who are watching?
Yes, I did.
Okay, sorry.
Yeah. Memorization
Thanks.
is super helpful, for sure. I'm terrible at memorizing things. I don't remember Brendan's name most of the time. I normally call him Brady.
That's not a joke.
Who's not here tonight.
It's not a joke.
Maybe not normally, but like a solid third of the time.
Yeah.
I call you Brady. The other
Or
third
Bob.
is Bob. Yeah.
And then you get my name right sometimes.
But I don't remember stuff. But I do try to, and this is what I try to teach people, is you want your brain to be super sticky. You want to build this scaffolding of understanding of things. That's why for the math section on the SAT and ACT, it's so important to have those basic concepts down. If you don't have those and you have holes in your knowledge there, you're going to be able to work through some really difficult imaginary numbers problem, but then at the very end with the fraction, you're going to see it and not know what to do. And you have to have those things, and all of the new information ideally is being integrated with the old information. So it's not necessarily about memorization. It is about having a full, deep understanding of stuff.
So I'm going to hop on this. You currently have the e-brake. At any point, pull this, and we'll cut it off.
I'm going to maybe start now.
No. So one of my teachers said the SATs and ACTs are just bad tests, and they aren't for everyone. I agree that they're not for everyone. I agree that it does not necessarily test well and is not something that is necessarily indicative of how intelligent you are or not. That is, I do agree with that. People with good grades are just memorizers. I think that's one of the most stupid things a teacher can tell a student is that if you have a good grade, it's just because you can memorize things. And if you have bad grades, it's because you can't memorize things. Like, I don't know.
True.
I mean, at a base level, like, sure, you can't remember them. But I think there's more problems with AKA a teacher who is not able to get something to stick than with the student who isn't remembering or memorizing the thing that teacher is trying to get by. I think that's... Anyway, people who are street smart will be successful. No, I have plenty of friends who are super street smart, and they're in jail because they're street smart. Because they're on the street a lot, and they're doing things that is street smart, which is lots of those things end up being illegal. I think that there are lots of things with that are horribly wrong, and I think it's a jaded sense of... It's a jaded perception. I think that I would agree with a lot of that on a very generalized thing, but not all of it together for sure. You can show them this, and then they can hate us. That's fine. But I would not take that word of advice to heart. I think that is a very great way to teach kids that they should not try. No, I get that. I understand, but some of the smartest street smart people I know are in jail right now. I also didn't come from a great neighborhood, but that's a different topic. Different time. BPL is not on our queue right now.
I would recommend pursuing both.
Yeah, I mean, that is what we said about having a social life, right? Street smart, in my opinion, is being able to communicate with anyone, right? Knowing how to talk to the CEO and knowing how to talk to the guy who's going to come in and fix your sink, who gets paid, $100K a year. Honestly, guys, college isn't for everybody, and you can make way more money doing other technical jobs. Again, not something people necessarily want to hear, but some people have to do those jobs, and they get paid a lot for it, guys. It's great. I have lots of people in my family who do that, and I have lots of good friends from high school who are making just bukus of cash. You like that word?
Mm-hmm.
Because I do. Anyway, back to the SAT and ACT after I just bashed college. Hi, moms and dads. Good to see you.
Okay.
Just
we have
so,
this
just so
equation.
They know, life lessons with Brendan.
Oh gosh, yeah. We have y equals 2x plus 1. We have negative 6x equals 3 minus 3y. And that doesn't actually help. What did I want here?
Are you impressed with my drawing, though?
Yeah.
It was all right. It wasn't amazing, but I thought it was pretty good.
So if the question is for what... Actually, it sort of just gave away the answer. But for what value of a, which is a constant, does this system have no solutions? So robot answer. Why don't you give this a shot real quick? For what value of a does this system of equations have no solutions?
Also, if that was your favorite teacher, I'm sorry.
I'm sure it wasn't.
But only if it's your favorite teacher.
There are a lot of scenarios in which that could have been said and it would have been totally valid. I think. So I need a better color.
As someone who's in education but definitely not a teacher, I just don't know if I like the fact that someone will be standing in front of kids one day telling them, school's not for you.
This is he said, she said.
I know.
He said,
she said?
There's some calculator programs.
She sells seashells by the seashore.
Yes. There are some calculator programs that actually solve systems of equations, slope, quadratics. Do you guys support those programs or think it's better to do? It's fine to have them on your calculator. Yeah. Not going to help you on the no calc section for the SAT. And they do actively try to ask questions that don't allow you to figure that out.
Or you have to figure out those values anyways to then plug in.
Yeah, so in this case, for example, a calculator wouldn't really help you because you have to reason out how to get no solutions. You could plug stuff in for A, but you can't plug this in and expect something to happen on your calculator, right? It's going to mess up because you have a third variable in this equation.
Yeah.
Okay? So we need to think about this graphically. That's the best way to do it.
But, sorry, to go back to that. Mm-hmm. However, for the test, yes, we definitely support them because it's going to be quicker lots of times. If you're comfortable with it, it can be a lot quicker. And because these are timed tests, especially the ACT, having those programs is very, very helpful and totally allowed, which I think is kind of bogus, but it's totally allowed. So I would say if you have it on your computer, on your calculator, make sure you know why it's there and how to use it.
Yes, sir. Yes.
Give you a couple minutes to do it.
Okay.
All right. Well, if you'd like to mute us, because we will be, or is this just specifically for him?
This is for him. Yeah. So why don't we let that hang out?
For the other viewers, ask us some questions.
Yeah, ask some questions. Oh, you know what? Now's a good time. So we're sponsored by two things.
Yes.
Companies.
We have two sponsors. We have two sponsors.
Institutions. One is this one, Alta Ipsum. The other one is our private tutoring. But this is Alta Ipsum. It means summit yourself in Latin, not in Greek, although it could if you're into that and make it up.
Loosely translated.
Summit yourself, very loosely translated.
Very loosely.
Summit yourself, make yourself better. It is an executive functioning app. So all you got to do, it's on your phone, it's on computer, it's web-based. It's for organizing, it's for planning, it's for grade tracking. It allows you to put in, let's say, a term paper 3 weeks away that's due. And you put that in and say it's due on this day, and then it'll give you a study schedule or a writing schedule. And then from there, you can customize it yourself. You can keep track of your grades. It tells you where you need to do more work. It tells you where your pain points are, that type of thing. You can record quizzes, tests, and then see where you need the most help, that type of thing. Yeah. You can also, with that, with their calendar, plug in Nerdish and go ahead and add that to your calendar so that you know every night that we're live to come and check us out and watch us. There you go, guys. Yep. It's useful. It's also, you get a free first month. Yeah. So might as well try. Mm-hmm. Also, Robot Dancer, if you're still doing this, this that I drew here was totally arbitrary. It has nothing to do with, or it does have stuff to do with these equations, but it's not the same thing. Is it 6? Yeah, it is. Nice. Okay, so I'm not sure if you did that algebraically or you did it graphically. I think it's important to understand the connection between the two. So if you have a system of equations, you can graph that system of equations. And these two are linear functions. So, ooh, I punched it again. Sorry if that hurt anybody's ears. I punched. Come on, Levi. Hey, Alta Ipsum. I did it by dividing the thing. Hey, by the dividing thing. There he is. Yeah, cool. Graphically, this is some random system of equations. And this is their intersection point graphically, which is also the solution to that system of equations, some x1, y1 pair, right? And then you could have an infinite, so this is one solution. Now, if you have a parabola like that, and you're just looking at this line and this function, you're going to have two solutions, two intersections. But let's talk about infinite solutions. If you have infinite solutions, and it's possible. This is a trick question, possibly. And then you could have two solutions where this is your line, and then, so that's two solutions, that's one solution. if you have two lines that are exactly the same thing, it's just kind of one on top of the other one, you have an infinite number of solutions. Any xy pair that fits one is going to fit the other and vice versa. Then you can have parallel lines that are like this. So I think this is what you may have done here. Because what really helps is putting them both in y equals mx plus b form. That makes it a little bit clearer. So let's have that. So we have y equals 2x plus 1. And then for this one, I'm going to add 3y, and I'm going to add ax. So that will give me, so that'll give me 3y equals ax plus 3. And then we're going to divide by 3. Divide everything by 3. That'll give us y equals a over 3x plus 1. Now, here's the issue. How about the negative 1/3 equals 2 over a way? Negative 1/3 equals 2 over a. I'm not exactly sure what that is. I think maybe you're dividing down. Or this. I'm not sure exactly what you mean by that, Robot Dancer. But in this case, we have an identical we have two almost identical equations. So be careful. If you say that 2 equals a over 3, because you're setting those two equal to each other, they have the same slope, then you'll get a equals 6, which is fine if you are going for this situation, where you have two lines that are the same line. They have an infinite number of solutions. This was a trick question because there is no value of a for which there are no solutions. There is a value of a, there are infinite values of a for which there are one solution. So if a is, let's say, 9, if a is 9, then this one becomes 3x plus 1. So if you're graphing 3x plus 1 and 2x plus 1, it's going to look like that, and it's going to look like that. And they intersect right at 0, 1. So any value of a that you choose, aside from 6, will give you one solution. If you choose 6 for a, you get infinite solutions. There is no way to get that, which is what this question was asking. A scenario where that would happen is, let's say this was, I don't know, 5? Nah, let's say 12 to start out. So if we just, I'm going to rewrite these equations as their own thing. I'll do it in orange now. So we have y equals 2x plus 1, and then I'll write it the way it should be, so add 3y, so we have y equals a over 3x plus 12. Now in this case, we do want the same slope, because having the same slope but a different y-intercept will give you, so we have one y-intercept at that, right there, and the other one will be at 12, so this is 12, this is 1, so we would be creating that situation, which is what we want. We want two parallel lines. Unfortunately, in this scenario, you can't create two parallel lines. They would just be the same line. Do you have any questions on that, Robot Dancer? Please let us know. Do we have any more Discord questions?
No, and we are pretty much out of time.
Oh, we are? Okay. Oh, yeah.
2 minutes.
Look at that.
Excuse me. Hey, excuse me. All right. And yes, for those of you who are asking, thank you. I do feel a lot better. I'm not nearly as sick as I was the other day. So I appreciate the concern that all of you have expressed via the chat and comments.
Find it. Oh, I'm trying to find what I was talking about, but I can't. Ah, okay. There is a way you can divide down. There is like a shorthand method for doing that type of problem. I don't think it will help because they can change one word in the question and it renders that approach not even useless but wrong. So I would stay away from that. What I would recommend is thinking of it graphically, because graphically is a little bit more easy for you to visualize than just seeing these weird equations. Put them into y equals mx plus b form, graph them if it helps. It's relation between two lines.
No say.
Yeah, I don't know. I don't know.
If you have an example tomorrow,
yeah,
we can go over it.
Bring back an example tomorrow. We can talk about it then. It seems like you're pretty good on math, though, Robot Dancer. Do you have any
English verbal questions?
English or reading questions, or maybe you don't know exactly what the problem is, or it seems to be different sporadic problems. No solution is a over 1
a1 over a2 equals b1 over b2.
Depending on where I don't know what the a's and b's would be necessarily.
Yeah, it's hard to say without given the equations. Equals infinite.
Oh, given that, so you have a, it doesn't actually matter, ay equals bx plus c 1 1 1, a2y equals b2x plus c2. Yes. Then if all of those are the same, then you could multiply by that factor that you're finding there. And then, so let's do this real quick. So if we have 2y equals 3x plus 4, and then we have, so no
it's all
solution.
the same proportion. So no solution is just a and b.
Yes, so no solution. I would say...
Yeah, because then you just have two parallel lines with a different circle.
Yeah, so you have a1 over a2 equals b1 over b2 does not equal c1 over c2. You need to include that because it's not implied.
Until after you give us the second one, which is...
Yeah,
that makes sense. I would say it's easier to just try to prove that the slopes are even than trying to remember that and regurgitate it on the test. Memorization is not key necessarily. I mean, in theory, for some reason, memorizing has a negative connotation nowadays. You are supposed to memorize it, but it's not for the sake of memorizing, right? You're supposed to learn something, which is the same thing as memorizing. It just has a different connotation. So you should learn it, which really just means to be able to remember it. So in effect, you're memorizing it, but do it and know why you're learning it, knowing why you're able to remember it. I think that's just foolish. But
cool.
Hey.
Have a good night, everybody.
All right.
We will be back tomorrow, which is Wednesday.
Ooh, but
not on Thursday.
And I'm gone mañana. Mañana, I'm gone. I'm not here tomorrow. So I'll see you all next Sunday. Wait, is it President's Day this weekend?
President's Day is Monday, yeah.
Are we doing streams that week?
Yeah.
Okay.
Yeah. I'm not here Sunday.
Oh, convenient. So what you mean is
that
I'm doing
weird
it.
accent? It's
Go ahead and look it up.
Christopher Walken.
Christopher Walken.
He's
this watch.
Yeah.
Is he
Ask
called
Brady.
this watch?
Ask Brady.
Brady's better.
Yeah, Brady's the best I've ever heard.
For context, I'm okay. Honestly, maybe good. And then Brady just makes me sound like I'm some guy hacking up a lung on the side of the street near the subway. But yeah, look up Christopher Walken. He's a great actor.
Have a good night, everybody.
See you guys.